2025 was not a great year for Ford's electric vehicle program by any measure. We saw the company cancel its electric pickup truck, the F-150 Lightning. They also told us that Ford's Blue Oval City in Tennessee, the plant that they were building to build electric pickup trucks, was not going to build electric pickup trucks. Instead, it was going to be a manufacturing plant for combustion vehicles. We're also told that some of their battery plants that were going to be making batteries for electric vehicles, the battery packs, would still be making batteries, but they would get put in energy storage systems. And then to top it off, the T3, or at least it was codenamed the T3, that was the next generation of Ford electric pickup trucks, was not going to come to fruition. Instead, the company was pivoting to an all-new platform, the UEV, or Universal Electric Vehicle Platform. However, we didn't get a lot of information on the UEV until today. And Ford's lead on the new UEV program, Alan Clarke, played a prominent role in that video. Now, Alan has been with Ford for about 4 years now, and he is their executive director of advanced EV development. Before joining Ford in 2022, Alan was with Tesla for more than 12 years, and he finished his tenure as the director of new programs engineering. So Alan's a heavyweight with regards to electric vehicle engineering, and Alan is coming on State of Charge here today to talk to me for about 20 minutes about the new UEV program. So what we're going to do here first is I'm going to play that video. It's about 14 minutes long that Ford published today. If you've seen it already, you can jump ahead of it. I'll have chapters in the description of this video, because right after that video ends, we're going to jump into my interview with Alan. With that said, let's get into it.
Last year, we introduced the Universal EV platform and production system at Louisville Assembly Plant. But this journey started years ago with a single ambitious goal: build great electric vehicles that are not just fun to drive, but genuinely compete on price with the best, including gas vehicles. An electric vehicle's battery can account for about 40% of its total expense, which is a major barrier to affordability. Thousands of people globally are working on reducing the cost of batteries, from the raw materials all the way to the ways that they're manufactured, to make them more affordable. But it's important to work in parallel on reducing the size of the battery in an electric vehicle. To address this, we needed to start completely from scratch, rethinking how we approach design, engineering, and manufacturing of a vehicle together as a team. Why such a radical shift? Electric vehicles are basically a massive physics challenge. We know that many customers expect more than 300 miles of range. And the solution up until now has been to install bigger, more expensive batteries. This increases the weight, and that requires even more energy to move around. And traditional vehicle designs tend to be aerodynamically inefficient, putting even more tax on the battery. We knew we could do better by focusing on one thing above all: efficiency. And we did this by arming every engineer working on the project with what we call bounties. Bounties are numerical metrics we assign to key factors like vehicle mass and aerodynamic drag, factors that directly translate to efficiency and therefore the range and the cost of the battery. In a low-cost vehicle, it can feel counterintuitive to increase the cost of a part just to decrease its weight. But if we can give that weight reduction a value in terms of the battery cost, then we can decide if making the part lighter and more expensive actually saves us more money than adding additional battery. Bounties guide our engineers to make these tough trade-offs. The aim is to reduce overall energy consumption of the vehicle as a system, not simply an optimization of a single part. It starts with our all-new midsize electric truck. Let me pass it over to Salim to talk about aerodynamics and parasitic friction.
Aerodynamics is a crucial part of an electric vehicle's performance, because every bit of inefficiency caused by drag robs you of range. At higher speeds, drag becomes even more significant. If you go twice as fast, the air holds you back 4 times as much, and you need 8 times more power to keep going that speed. Our designers and engineers across all disciplines worked hand in hand with our own team of ex-Formula One aerodynamicists to make the truck not only look great, but perform even better. Together, we obsessed over our bounty targets. Just like in racing, where everyone is united in shaving milliseconds off lap times, the bounties keep us focused on chasing physics. When we finally achieved our target, we reset it to continue challenging ourselves and go even further. One small improvement, let's say a millimeter change in the roof height, equates to a $1.30 savings of battery cost. And as a result, the aerodynamic efficiency of our truck is more than 15% better than any other pickup truck on the market today, and will ultimately result in longer range and lower costs for our customers. If we go underneath the vehicle, you can see how we streamlined the underbody to manage the air. Starting at the front, we made the bolt holes shallower and carefully directed air around the tire and suspension. We also painstakingly designed underneath the car to steer the front tire wakes directly onto the rear tires, hiding them from the high-speed flow and ultimately reducing drag. Changes like this can contribute to an estimated 4.5 more miles of range for the customer. Moving to the back of the car, we position the drive units as low as possible to reduce the angle of the half shafts, making them last longer and minimizing wasted energy caused by friction in the joints. We then sculpted the motor case to allow the air we carefully managed at the front pass under the vehicle uninterrupted to reduce the size of the wake. Here, the roof was sculpted to carefully shed the high-speed air on top in a teardrop shape over the bed, creating a virtual surface for the air to completely skip over it. To the air, it's no longer a truck. We also applied the same mindset to the side mirrors. Instead of separate motors for glass adjustment and another motor for folding, we've merged those functions into a single actuator. The entire body of the mirror now moves. The mirror body size is now more than 20% smaller than a conventional mirror, which reduces mass, saves on costs, and unlocks a more aerodynamic shape, resulting in 1.5 miles more range for the vehicle. We also needed to reduce mechanical friction, so the team obsessed over every single bearing, seal, and joint inside the vehicle. We treated the drive unit oil management system just like a race car. Our control software, which can be updated and improved over the air, adjusts the speed of the electric oil pump so it runs at the lowest speed possible to cool the motors and lubricate the gears, while carefully designed jets and baffles reduce windage inside the gear case. And to make sure we aren't letting any energy go to waste, we enhanced the design of our regenerative brake system, which, like all electric vehicles, captures the kinetic energy, converting it into usable electric power for the high voltage battery. Our new design will save us around $100 in battery costs. The result of all this work? If the same battery was married to the aerodynamics of the most aerodynamically efficient mid-sized gas truck in the US, we believe our new electric truck would have nearly 50 miles or 15% more driving range and a 30% improvement at highway speeds. That's what happens when every curve, every surface, every detail has been obsessed over and over again, and works together as a system. Now let me turn it over to Vlad to talk about the vehicle structure.
Weight is another one of our greatest efficiency robbers. Our engineering team had a philosophy: the best part is no part. If the part is necessary, then it must serve multiple purposes. It's not easy to find those opportunities. That is why we need the close collaboration of a small, nimble team. So first, we focused on reducing one of our biggest contributors to the vehicle weight, body structure.
To do this, Ford is using large aluminum unicastings for the first time.
These unicastings make the structure significantly lighter, delivering more than 27% advantage in casting weight over our competitors. They also serve as a structural element of the mixed metal body structure architecture, which is the backbone for both vehicle and assembly process. To put a finer point on it, by comparison to the Maverick, has 146 structural parts in the front and the rear structure. The mid-size electric pickup truck will have 2 parts. Using unicastings, enables 25% fewer fasteners than typical program. With reduction in parts comes reduction in joints, sealing, therefore robots in the factory, giving us immeasurable gains in product quality and the throughput. Let me hand it over to Alan to talk about the battery.
Now let's take a look at another big contributor to weight, the battery. Our holistic focus led the team to select a low-cost chemistry called lithium iron phosphate, or LFP. With no nickel or cobalt, our battery cell contains lower-cost ingredients over other battery chemistries. Next, we focused on the packing of the battery cells. Think of it like a puzzle. We're trying to fit the most battery material possible inside the pack. Our prismatic LFP form factor enables an incredibly efficient cell-to-structure architecture. This architecture essentially turns the battery into an integral part of the truck's skeleton. The battery pack also uses a multi-layer, single-piece, flexible circuit board. This board integrates low voltage, high voltage, and thermal sensing connections, reducing hundreds of bus bars and wires into a single part. We can measure voltage and temperature and connect each cell using this hyper-efficient module. Overall, the cell-to-structure architecture reduces non-cell cost. It also works together with a super compact, in-house designed power electronics inside the battery pack. This eliminates extra connectors, enclosures, mass, and overall volume. Instead of carrying the cells, this new architecture couples the cells directly to the structure. This makes the cabin quieter and the structure more capable of excellent dynamic performance. It's also a key enabler in delivering our new universal production system, which means our family of electric vehicles will be super fun to drive, a non-negotiable here at Ford. And let's not forget, we're using proven, long-lasting battery cell technology that ships in millions of vehicles today. We then married this battery technology with Ford's new innovative approach to make these cells into a pack. We'll be making the battery cells right here in the United States at Blue Oval Battery Park in Marshall, Michigan. Now let me turn it over to Lucas to share more about our electric vehicle architecture.
Okay, this is where we get a little more technical, but stay with me here. Vlad already told you about our philosophy, and you see it come to life in our approach to the vehicle's electrical architecture too. I joined the team 2 years ago when Ford acquired Automotive Power. At AMP, we specialize in pushing the limits of energy management, and we've brought that expertise here to optimize hardware and software for faster charging and smarter battery performance. With this platform, we're moving to a zonal architecture, where we're integrating multiple vehicle functions into a small number of modules. Conventional vehicles are built with over 30 scattered electronic control units, or ECUs, which are the brains of the vehicle. In the past, they were individually housed and sourced from various suppliers. This results in a tangled web of connectors and wiring, adding complexity and weight and cost to both manufacturing and assembly. Our platform combined those into 5 main modules, drastically reducing cost and complexity of the wire harness. We're also moving from a 12-volt system to a 48-volt system, which allows us to reduce the copper thickness of the harness. In fact, these changes helped us make the mid-size electric truck's wire harness 4,000 feet shorter and 22 pounds lighter than one of our first-gen electric vehicles. We did not stop this consolidation effort on the zonal modules, but carried the same philosophy to the power electronic components, which are the muscles of an electric vehicle. For example, the DC to DC converter, which converts the 400 volts battery power to 48 volts, now shares a board and components with the AC to DC charger. This single module also manages power distribution, battery management, and provides AC power back to your home during an outage. Grouping these together allowed us to consolidate common parts such as sensors and auxiliary supplies, reducing the number of components and printed circuit boards. This resulted in a surprisingly small and serviceable unit. Despite all its capabilities, it's elegant in its simplicity, and we call it the E-Box. Lastly, I want to talk a bit about some of the diagnostics we intend to run on the battery packs. We're leveraging machine learning to create a predictive model for the battery pack, which will track and adapt its usage based on both historical data and real-world conditions. This will, for example, allow us to adjust charging rates to help prevent degradation of the battery over time. Let me turn it back to Alan.
That's how the team is collaborating to develop the platform. We're using a true systems engineering approach across design, product development, software engineering, supply chain, and manufacturing to completely rethink vehicle production. Every decision centers on how much we can reduce the size of the battery. How can we give more to the customer so they get better value? For our industry to truly unlock the transformative potential of electric vehicles, this strategic integration is foundational to achieve cost parity with gas vehicles. Gas cars have been optimized over the last 100 years, but there are still countless ideas for reducing the cost and increasing the capabilities of electric vehicles. The technology, engineering, creativity, and innovation are already happening. We need to scale these advancements and deliver them to driveways across America and around the world. We can't wait to share more as we continue on our path to deliver our universal EV platform and a family of compelling and fun to drive affordable electric vehicles. Thanks for coming along for the ride. We can't wait to get you behind the wheel.
This video is brought to you by EVChargingStations.com. If you're serious about EV charging, this site covers everything. My home charger reviews, fast charging tests, and all the latest industry news. There's a section to help you compare EV charging equipment and accessories and click through to make a purchase. Visit EVChargingStations.com and power up your EV charging knowledge. So I'm here today with Alan Clarke. Alan is the Executive Director of Advanced EV Development for Ford and the lead on the new Universal Electric Vehicle platform. Alan, thanks for joining me here today.
Absolutely happy to be here. Thanks for having me again.
Okay, so we finally got some news about the new UEV platform. You know, a lot of people have been dying to get something out of Ford about this. You've given us little dribs and drabs, but we finally got something that we could sink our teeth into. And, the Ford EV owners and aficionados really appreciate it. So let's before we jump into some of the questions about the video that you guys put out today, I have just a general question. Was there like a defining moment that Ford realized the path they were taking with regards to electric trucks? And, you know, I have a Lightning. I love my Lightning, but I understand it has to be profitable. You have to be able to make money on it in order for it to exist. But was there a defining moment when you guys realized, look, we need to do a reset here. We need to take a different path. T3 isn't the right path forward. We need to start over.
That's a good question. I can't say that I've been part of any conversation where that realization was made. And it may have happened before I even joined the company 4 years ago. And it's possible that the leadership realized that we could run multiple solutions in parallel, or it's possible that they looked at it as a bet. And I think the UEV platform, the skunkworks itself, was labeled as a bet for quite some time. And I think Jim talks publicly about it being Ford's biggest bet now. So yeah, I think it's very unlikely in my mind, and certainly I'm not in all those different conversations talking about how is Ford going to change its direction in EVs. And many of those conversations happened long before I joined the company. But at the end of the day, the decision makers have access to the results, which is how much does it cost? How compelling is it to customers? How much capital is it going to cost to put into production? And they make decisions based on all of that data. My team's focus has been on making the lowest cost, most compelling, affordable EV possible with the constraints that we have since day one. And, I think we try to our best abilities, ignore as much of the noise around externalities that we can't control, and that's one of those things we sort of see as we can't control it. We're just trying to make the best EVs possible.
Interesting. So since you've been with Ford, you've been working on this same program. It's not like you were working on T3 and then they said, okay, look, we're going in a new direction. You've been hammering at this since you've been with the company.
Yes, and that's a unique gift in focus. And everyone who's been working on this has had, typically automotive companies, they have a factory that, and by factory I mean an engineering factory that develops and launches a product. And in our case, we've had a myopic focus from day one. And that means hyper optimization on this platform, this set of products, and not dealing with all the constraints of the multitude of products that Ford works on at any given time has been a gift that's allowed us to focus and optimize.
One of the things that stood out in the video was that they had said that the universal EV platform reduces parts by 20% versus a typical Ford program. But EVs aren't typical. They already have less parts. So to me, that it was a little odd. I was saying to myself, well, I would think a Lightning might have 20% less parts than a Ford F-150 hybrid. Explain that number a little bit. Does the new universal EV platform have even less parts than the Mustang Mach-E?
Yeah, it's basically compared to our first generation of electric vehicles, which I suppose we're our second generation in reality of EVs. It's really tough to compare, right? You can't just rip out one powertrain and put another powertrain in and then give a set of numbers and it's like to like. We also know that the slope of improvement in EVs is extremely steep versus the slope of improvement in ICE. We're on a 120-year asymptote that we're not getting much closer to optimization at this point.
Exactly. And also you have the 800-pound gorilla in the room, China, putting out new platforms and new versions of their vehicles like in months, not years, that you have to kind of keep up with. The video also talked a lot about aerodynamics and how it plays a big role and how much you guys are really focusing on bringing people in and working on the vehicle that have extensive aerodynamic backgrounds to reduce, the parasitic friction and so forth. Now, I have access to a lot of companies, and they all talk about how aero is so important these days and how they're so laser focused on reducing a slight bump in the vehicle that might add a little to the aero. Could you talk a little bit about, it almost seems like you guys are taking it one step farther, and why that's so important?
Yeah, I think it's also just, you can probably hire the best aerodynamicists in the world and then put them in an environment where they actually can't perform or deliver anything. And so I think a good part of this has been getting the technical competence with the mindset, with the psychology and organizational structure to allow those people to actually deliver high quality results. So, I think first of all, people who come from Formula One, they have a very interesting mindset. They have the rules, physics, and the cost cap to work around. But for the most part, it's all about performance. So you get this mindset of really pushing up against the limit of all of those things together. And they're incredibly creative engineers typically, and they think about themselves not just as engineers, but also as designers and creatives. So if you put those people next to designers, because I think it'd be quite easy to make an ultra efficient mid-sized pickup truck. It's very hard to make one that's also aesthetically desirable and makes you want to buy it and tugs at the heartstrings, because ultimately automotive is going to be, or it still is today at least, a very emotional purchase for a lot of people. You have to have a desire to actually want to buy that thing, and the shape of it is important to do that. And I think one thing we don't have as a constraint is in Formula One, the number of hours you can run, the types of CPUs you can run CFD on, even the scale of testing is limited. So get some aerodynamicists, put them next to a bunch of designers, and then give them full-scale wind tunnels, give them whatever CPU and compute capability, whatever CFD software they want, have them build custom tool sets, and then you create this virtuous cycle of continuous improvement that I think is probably quite different than other companies have set up these teams for success in delivering products.
How about the unit casting? So, since Tesla kind of introduced, I think they call it gigacasting in 2020 with the Model Y. And at the time you were with Tesla. You came over to Ford in 2022. You were with Tesla for like 14 years, something like that. I don't think a lot of people understand how big of a step forward the unit castings are, and how much time and parts savings they have. Could you talk a little bit about the importance of that, and even do you expect that to spread across Ford's other offerings in the future?
Sure. I mean, there's the obvious one, which is 146 parts down to 2. And that's compared to another mid-sized truck that we make. And so that's the obvious one. The second less obvious one is the best part is no part, but the second best part is one that has multiple functions. It's basically putting more functions into that casting so that you can delete other parts. That's incredibly important. The actual production line to make those unit castings is profoundly different. Instead of tens or dozens of robots and individual stations and start-stop stations that have to move a bunch of smaller parts that get put in with welding robots, you have one die-cast machine, a trim press, a water quench. The infrastructure itself is significantly less. You have to be really good at predicting what you're going to get, though. And so you have to develop an entirely new tool chain, a new mindset. And, I think one thing that shouldn't be lost here, though, is that we're not first to the party with large unit castings. And Ford has experience, like on the Explorer with a shock top that was made of castings, and we make transmission housings and engines that are high pressure die cast as well. So Ford has the experience, but most importantly, Ford has the optimization capability. So that's why we've actually been able to make these significantly lighter than examples that are on the market today. Nets in savings of everything in terms of the amount of mass in the product, but also the size of the dies you have to produce in order to create those parts. So again, creating the whole tool set to be able to deliver unit castings like this will continue to help Ford, I think, quite a bit in the future. It's that continuous virtuous cycle of you get the capability, you design the product, you learn a lot from it, you deploy it again, and then you continuously improve.
And let's talk a little bit about the choice of battery cell composition. You're using the lithium iron phosphate, which is LFP batteries that are made in Ford's Marshall, Michigan plant. LFP batteries have advantages, they have disadvantages. And one of the things that strikes me is that one of their disadvantages, they're not as energy dense as some of the other chemistries. So you need more of them in order to get the same result, which then adds weight. And Ford is so laser focused on reducing weight and making this vehicle more efficient, so it needs less battery cells. And then you're using a battery chemistry that, let's say, needs more cells, more weight to gain the same amount of driving range. Could you talk a little bit about that trade-off? Like, would the vehicle possibly be available in other chemistries also? I know Ford has done that in the past, where certain models have LFP, certain models have a different chemistry. Talk a little bit about that trade-off, because it's not a slam dunk to say this is the right cell for this, in my opinion.
Yeah, I'd agree with that. You're right that it's coming from Blue Oval Battery Park. When we talk about the bounty culture and the bounties methodology that we use, the root of that is a really strong understanding of the vehicle performance under a lot of different conditions, the way that our customers operate the vehicle. That model was used to define which battery chemistry made the most sense. So, there are trade-offs, there are penalties with the low specific energy and volumetric energy density of a lithium ion phosphate. We overcome those by saving mass in other ways. We overcome those by structurally coupling the prismatic battery to the structure of the pack itself, making it part of the floor structure of the vehicle. So all of those things, I think, make the penalty lower of using lithium ion phosphate. But you're spot on that it is a trade-off. More than 80% of the Chinese vehicles sold today are lithium ion phosphate. And so there's, as you can imagine, a massive amount of development effort going into everything from the raw materials through to future advances in chemistries of lithium ion phosphate in that form factor as well. So I think it's not just a bet on what can we deliver today. It's also a bet on what we can deliver as time goes on. We've said a couple times we will have a diversity of different chemistries over time. So this is just the first one we're coming to market with, but I think any good platform will have agility and capability to pivot to other chemistries, and this one is no exception to that. But I also think, and this is the last thing I'll say about LFP, there's a magic in bidirectional that hasn't been realized by the automotive industry yet. And when you can start sending energy back to the grid and backing up your house on a regular basis, it will be very compelling to customers. And to do that, you need a very durable battery chemistry. And lithium iron phosphate has amazing throughput capabilities through its life.
Don't forget, I can send energy back to my house from my Ford F-150 Lightning right now with this guy right behind me. So I'm very interested in seeing what you guys have in store with the next generation truck. And staying on the same topic of battery. Now, I know we're not talking battery size and range and everything. I'd love to get into the weeds of that, but the timing's not there for that yet. But I do have to bring up that earlier in the middle of last year, I think it was around August, there was a press briefing, and Ford said that the battery in this truck was going to be 15% smaller than that of the BYD Atto 3, which is an electric crossover from China. And that has about 60 kilowatt hour of usable energy, which means this truck should be at about 51 kilowatt hour of usable energy. I mean, that's already out there. That Ford made that statement. Is that still the plan, or has something changed in the last 8 months?
I'm not going to confirm battery sizes, but I will say that just like we talked about in terms of multiple chemistries being necessary for it to be a successful platform, but also multiple battery sizes are necessary, because I think there's some customers who they still want hundreds of miles of range, and there's others that they've already driven EVs and they've realized that one of their EVs they want to have a really long range, and one they want to pay a lot less money for it and have a much shorter range because it can deal with their grocery shopping and their daily commute, and as long as it can fast charge, it fits their needs. So I won't say you're wrong. We talked in the video about the specific use case where we know customers want over 300 miles of range. That's a very important number to them. And delivering that with a smaller battery so that they can ultimately pay less money for the vehicle sort of then directly connects to the fact that a lot of these customers who are buying the vehicles in the class that we're talking about, it's not that they can't afford a more expensive vehicle, it's that they're focused on value. Is they don't want to pay more for it. And they're looking at, all right, I want to get lots of miles. I want to get the feature content. I want to get something that's aesthetically desirable. And in our case, we're making sure that it's really fun to drive. And so it's the whole package of, the EV that ultimately is not the cheap EV. It's the one that's really compelling. And they talk about the value of it more than they talk about the cost.
I think that's a great philosophy, offering entry-level one with the biggest battery to keep the price down. You mentioned a $30,000 starting price. There's a lot of people that can live just fine with a small battery and not a lot of range with electric vehicles. Not everybody needs the 1,000-mile battery, and especially with infrastructure getting better and better these days, and the network's just expanding. If being able to fast charge is ubiquitous, it's all over the place, you don't really need to lug around that weight unless you're a real high mileage driver. So I think that's a good strategy, and offering a larger pack for the people that want the range, that makes sense also, because there's still areas of the country where you do need more driving range. Middle America is different than the coast. So good strategy there. Okay, zonal architecture. 48-volt battery system. I was able to go to a Rivian event last year, do a real deep dive, immersive thing in their zonal architecture, and I found it fascinating. I think that's the future of automotive. So it's good to hear that you're incorporating this in your vehicle. Talk a little bit about the advantages and why it's such a huge step forward. It's not a little step forward. The zonal architecture and the amount of weight reduction and the amount of wire reduction. So maybe let people know a little bit about that.
There's very few automotive companies that have been able to achieve a true zonal architecture. I think there's many that are out there today that are called zonal architectures by marketing terminology, at least, but zonal architectures actually distribute their compute capability and change where the functions are actually happening within the vehicle. The physical topology that's actually optimized is primarily around how the energy and communication is then distributed to the vehicle. So, zonal architecture will help you with shorter wire runs, less complexity in terms of the actual hardware, and you drive some of that complexity into software, which if you control, you can make some really good decisions about how you then write, develop, and create software for a zonal architecture. But I think Ford was really smart far before I got here. I would say that one of the hardest parts of making a zonal architecture is having a software team and a hardware team that's tied at the hips, making good decisions and developing those products. But far before I got here, Ford took over a hardware division from a handset manufacturer, and they've been a key part of developing our own hardware. And developing our own hardware with software engineers in the loop has made us realize that we've made a bunch of different decisions around the selection of the devices that are inside those zonal modules and how they interact with the rest of the vehicle. And that's been a huge step forward, having that head start. I think if we didn't have that head start of all those super smart hardware engineers already inside the company, I'm not sure we would have been able to get up to speed actually making a zonal architecture as quickly as we've been able to.
Very good. I know we're up against it, so I got one last question. And this is it's from my personal experience. As I've said many times in many shows and podcasts, I love my F-150 Lightning. It's one of my favorite electric vehicles, and I'm going to hold on to it for a while. But the one thing that I would say it's lacking in is user experience, the user interface. It seems like it's a generation or two behind some of the cutting edge new vehicles, electric vehicles. I know that hasn't been talked about much yet with the UEV, but could you give us give us a little hope that this next generation is going to have the type of user experience that, say, some of the people have experienced with some of the newer cutting edge electric vehicles?
You're laying out the red carpet for me to just say, yes, Tom, it will have all of those things.
That's what I want to hear, because I might buy one of these new trucks. So, that's the one thing that I feel like the Lightning's lacking in. So hopefully you're doing some secret sauce on the new vehicle.
It's going to be next level. I think that it's so tough because we're talking so much about it being ultra efficient, high value, low cost. But the thing that's really important to us is that we haven't stripped out all the features. We haven't made it, a very basic truck. It has tons of feature content. The interactions with the infotainment in the vehicle are very rich in their experience. We know that people buying EVs care a lot about the digital experience, how it interacts with their phone, how it interacts with the cloud, how often they're getting software updates with new feature content. And, to me, that is a bare minimum of a new platform like this. And we've future-proofed so much into this platform in cell chemistry, in the zonal architecture, and in the compute to make sure that we can give an amazing digital experience to the customer. So, we have a lot of proof to show you to get there. But, and it's not easy. The team is working really hard on it right now. But we're hoping to show more of that in the coming months, and that'll hopefully prove me right.
All right. Well, I'm looking forward to checking it out, and more information on the UEV as soon as Ford is ready to release it. Alan, thank you very much for joining me here today. I really appreciate it. I know this is a pretty busy day for you, so I really appreciate you taking the time to come and talk to the State of Charge community.
You got it. Great to see you again. Thanks for having me.
And once again, I'd like to thank Alan for coming on State of Charge here again today. I know today was an extremely busy day for him, so I really appreciate him taking time out of his busy schedule just to chat with me here at State of Charge. So we learned today a few things about the new Universal EV platform. We know that it's going to have unicastings now. We know that it'll have a zonal architecture with a 48-volt system. There's going to be multiple battery sizes and even different battery chemistries in the future will be offered, even though they're going to focus on LFP initially. The video also talked a lot about the emphasis that was put on efficiency and lightweighting, using less parts, going farther with less battery, and that they expect the results to net them nearly 50 miles of range compared to a conventional pickup truck in the same class, and that it would be 30% more efficient at highway speeds due to the extreme emphasis and the advancements they've made on the aerodynamics of the vehicle. The truck is set to launch sometime in 2027, next year, as a 2028 model year vehicle. And the starting price is supposed to be at around $30,000. That would be pretty amazing if they can come in at $30,000, even with the smallest battery offering. There's very few electric vehicles today that can have a starting MSRP at under $30,000. So if they're able to match that, I think even with a small battery pack and not very long driving range, the vehicle will probably do very well. I'd like to know your thoughts on this topic and what was learned today. What lingering questions do you have? Now, I know driving range and charging speeds and all that, Ford just isn't ready to talk about that just yet. But I suspect they will be maybe around summer of this year. We might get some more information, hopefully. And I'll be right there to capture it and disseminate it to you guys. But based on what we've learned so far, please leave your thoughts and opinions in the comment section of this video, because I'm really curious to hear what the general public thinks about what Ford put out here today. And if this is your first time here at State of Charge, please hit that subscribe button and ring the notification bell so you don't miss any upcoming electric vehicle news and reviews. And as always, thanks for watching.